Jaswant.
Sir, yes, sir.
Okay. See, now actually this is a new tool from the company called Cadence. Okay. This
Yes,
tool
sir.
is used for simulation. The package is NC Launch and NC Sim the tools. Okay. So what we have to do is first let me create one directory saying mkdir make directory uh, Jashwant. I'm just creating one directory. Then I'm just going to cd Jashwant. Moving to the Jashwant directory. Then I'm just creating one more directory in the Jashwant uh, directory saying mkdir RTL. So I'm just creating one more directory inside the Jashwant saying RTL. That is register transfer level. Okay. So once the RTL is created, you go to change directory cd RTL. Then inside the RTL, you just go for text editor gedit. Let me say full.v full.v. Then you'll get a text editor. Quickly you have to type the program. So module full within bracket I have to say yes comma cout comma a comma b comma cin. Then I have to declare the input a comma b comma cin. Then I have to declare the output s comma cout. Then so let me go for structural. So let me define some wires here. So w1 w2 w3 semicolon. Now I'm calling XOR primitive for making a sum. So s comma a comma b comma cin. So applying all the inputs to the exclusive OR gate ABC in. Then I'm making three products A, B, B, C, C, A for generating the carry. So for that I'm using AND gate and. So let me put X2. So within bracket. So W1 is my first output of AND gate. So product is A comma B semicolon. Then again AND instant name X3. So the output is W2. The product is B C in B comma C in. Then say semicolon. Then again AND X4. So for creating one more product. So the output is W3. Inputs are A comma Cn AC. So now AB, BC, CA all the products are generated. Now we have to feed the product to the OR gate. So OR X5. So the output of OR gate is Cout. So inputs for the OR gate is W1, W2, W3 semicolon. So now the next last line is end module. So now quickly the program for full adder is ready. Full.v is ready. So let me check the syntax once again. Module F. Okay. Input, output declaration, intermediates, XOR, AB, BC, CA is passed to R. Okay. So now quickly full adder program is ready. Let me save this. Then close this text editor. Then go back to Jaswant folder RTL. Create one more text editor gedit. Say full underscore test dot v. So this full test dot v we have to define the test bench for testing the full adder. So let me write the Verilog HDL for full adder test bench. So module full underscore test. So open closed bracket. Don't mention any variables. Just close that with semicolon. Then in test bench we have to declare all the inputs as range. So range a comma b comma cin. So in test bench all the outputs we have to declare as var. So var s comma cout semicolon. Then we have to call the module whatever we are going to test. Okay, so the module name is full. So let me give some instant name x1. So the list of ports is s comma cout comma a comma b comma cin, a comma b comma cin semicolon. So now the full adder is called for the simulation. So now we have to go for the procedural statement initial, then say begin. So now let me put a equal to 1 bit binary 0, then b equal to again 1 bit binary 1 semicolon, cin equal to 1 bit binary 1. So I'm giving 0 1 1. Okay, so any combination you can give. So I applied 0 1 1 as first data, then I'm giving some delay. So after 5, so apply a equal to 1 bit binary 1 semicolon, b equal to again 1 bit binary 1 semicolon, cin which is equal to 1 bit binary 1. So now applying 111 after 5. So next let me test only two possibilities. No need to represent all the possibilities. So if you want you can add, nothing wrong in that. Let me copy the two lines and use the same line for generating the next case. 0 1 1. Okay, so 1 1 1. Let me introduce one more case. After say 10, a equal to 1 bit binary 1, b equal to 1 bit binary 0, cin equal to 1 bit binary, so 101 is the data. So now I'm just closing the begin, closing the module. So now full adder underscore test. So test bench for full adder is ready. Initial begin. So three combinations 0 1 1 111 101. Okay. So now save this test bench. So next, so before that we'll fix the time scale. Time scale 1ns slash 1ps. Save this. Okay, so now actually I created two files in your RTL directory. Okay, full.v, full underscore test.v. So two Verilog files I created. So now I'm just invoking the tool. So tool invoking command actually is nc launch. Okay, nc launch space ampersand. So it will invoke the tool nc launch. This tool is from Cadence. So now actually we have to set the directory first. So go to set design directory. So now actually I created one folder actually as G.Viswanathan. So I'm just going for that. Go to MRS. So there G.Viswanathan I created, right? So now you go create cds.lib file, save, include default libraries, say okay. Then again work library is created, okay. So now I am in G.Viswanathan directory. So in this G.Viswanathan directory, I have two Verilog files, whatever I created, full.v, full test.v. If you want to see Verilog, you can go to right click edit. So you'll come to know the Verilog HDL, whatever you mentioned. Okay. So now what we have to do is we have to compile both the test bench as well as the Verilog. First, let me select full.v. So let me go for the compilation. Okay, so now the compilation is successful. So again, select full adder underscore test. So go for the compilation. Again, both the test bench as well as Verilog is compiled successfully. So now what we have to do is we have to go to work lab. So in work lab, actually, you will be identifying two folder, full and full underscore test. Full is the module and full underscore test is the test bench module. So now you select full, right click, you ask one more tool for elaboration. That tool is called NC Lab. Then say OK. So it will continue the elaboration of your Verilog. Then select the test bench. Again, call the elaboration tool. Say OK. So test bench is elaborated. Now you go to the snapshot folder. So in that snapshot folder, you have to select test bench. You should not select the module, since if you select the test bench module, directly you can run in your waveform window. So let me select this work lab full underscore test module, right click. So invoking the tool NC simulator. Okay, that is the tool for simulation, NC sim. Say okay. So it is very similar like a model sim, whatever we practiced. Okay, so now actually all the full underscore test is ready. Now if you select full underscore test, all the variables whatever you declared as input and output is visible here. So select all the variables A, B, C, N, C out and yes, right click, send to waveform window. Then the variables are moved to the waveform window. So now directly there is an option to run this simulation. So just run. Okay, so now minimize this. So we applied actually three possibilities, right? So we'll check all three possibilities now. So in test bench we applied three possibilities. So the first possibility is 0, 1, 1, whatever we tried, correct? So 0, 1, 1.
Yes, sir.
So 0, 1, 1 gives you C out as 1, sum as 0, correct? So next
Yes,
case
sir.
is, next case we applied as 1, 1, 1, 1. That is all 1. So your sum is 1, carry is 1, correct? Then go to that
Yes, sir.
last. So now you applied 1, 0, 1. So 1, 0, 1 also C out is 1, sum is 0.